Okay, I'm back again. Right, so where were we? Okay, so we'd loaded in the data, we'd set the bytes to FF, we'd set the address to 00, and we'd actually read in using the block read function FF bytes, but we did it twice, and so the data was actually showing up in this window here, as you can see. And if I put the mouse over it, and this is why I like a mouse, you can see the mouse, and if I use the scroll wheel I can actually go up and down the data. As you can see, the data is currently sitting at 0 because it's not connected to anything, so you're going to read in 0 effectively. And as you can see, it's got all the data there for the second lot, and there's the data for the first lot. And it's concurrent, so it starts off at address 0000, goes up to 00FE, and then it starts off again at 00FF and goes up to 01FD, and obviously the next address will be 01FE, which is what I explained before. So obviously if you don't change anything in the address window there and click write address, the tester will continue on where it left off effectively. So if you wanted to read the entire contents of, say, a ROM, you could set the bytes to the ROM size, the address, the start address of the ROM, read it all in, and then if you wanted to read the next ROM, click block read again and it will read the next ROM, and so on, for the same amount of data effectively. The other thing it will also do, as you can see, is down the bottom, hopefully you can see this, it says a data.txt file is created. So anything you read in with a block read, it will put it into a text file and store it in the home, Pi, desktop and the ROMs folder. So you'll have a data.txt file in there which will have all the information that you see on this screen. It will be stored in a text file, so you can pull that in, you can put it on a USB stick, take it to your laptop, you could copy it, print it, whatever you want to do. It's just a standard text file. Every time you do a block read, it will overwrite that text file, so you'll only have one text file at any one time. So basically all these buttons along here are all the main functions of the tester, the basic functions. Down the bottom you have the special functions, so you have down the bottom you have test, which will allow you to do test programs, run them. So if I click that, you can touch all these buttons as well because it's a touch screen. You can see you get a different screen coming up, and this is actually for test programs, and I'll do another video later on which will go through the test. If you want to close down any of these windows, you have to go up the top and press a little X at the top right hand corner, and that closes them down, and you'll always go back to the window before it. So if you want the edit one, which is the same as the test program one, but this one allows you to edit the test program and create test programs. So with this screen here you have all the functions like replace, append, delete, insert, and I'll do another video showing all this as well, but basically that allows you to create test programs, which I call them test sequences, so you can store them for different boards and then you can run them with the other button that I just clicked before. ADT, that's the active device tester, and that one basically checks pretty much most logic devices live on the board. So the board has to be powered up for this to function. If I click it, you'll see you'll get the ADT screen coming up. It shows you a 20-pin typical device. You have an option to put a device name in, a number of pins, and you've got some tests you can run there as well. Again, I'll do a separate video showing that. That one allows you to check, say, 74LS00, 74LS245s, whatever, and it does it on the board when the board's powered up, and it has no real effect on the board or its operation. It does have a small effect if you put it onto, say, a clock circuit or maybe a video circuit. You might get a few glitches due to the extra wiring and capacitance and all that, but most of the time it won't have any effect, and it will actually check the chip and tell you whether the chip is good or bad effectively. So we'll close that one down again. ID check is a special function which basically does a block read. So when you do an ID check, it does a block read, so you have to set up the number of bytes and the address before you do ID check, and what that will do is it will read in a block of data and it will then produce a CRC32 value for that data, and it will compare it to tables, to files it already has stored. So at the moment it's got all the MAME ROMs stored in it, which amounts to about 2,000 or so, and they all have a CRC attached to them. So it will go through and it will try and match it to one of those. If it matches it, it will come up and tell you what the board is and what the ROM is, etc. If it doesn't match it, it gives you the option to put that in. So it might be a new board that it doesn't know, and you can actually store that if you wanted to. Probe is to do with the probe. So at the moment it's set to a digital probe, which is indicated by the D. If I click probe, you'll see it will change, and you'll get an A, which indicates an analog probe. So now the probe is actually set to analog, which means it will function as a voltmeter. So these figures over here are basically a DC voltmeter. It will read positive DC values up to 100 volt, and it will do it in two ranges. So the first range is 0 to 10, the second range is 10 to 100, and it will display the voltage there. Obviously if you want an extremely accurate voltage measurement, then you really need to get a proper multimeter, etc. But for most purposes it will give you a pretty good idea of the voltage, and it is fairly accurate on some of the ranges. The other thing you can also do is you can click here, which is an audio amp, and I'll just point that out so you can see it. It says audio amp on or off. So at the moment it's off. If you put it to on, you can hear it is now an amplifier switched on, so whatever the probe is touching, it will feed it through to an amplifier. You can use that for tracing audio signals as well. You can use that on the digital and the analog function, but it's probably best on the analog, and you can turn it off again with that. It also tells you here audio amp enabled or disabled, analog probe enabled, digital probe enabled, that sort of stuff. Clear I've already done, so you do clear, you see it clears the display. Help does all the help, I'll show you that. There you go, and then again, moving it over there with a scroll wheel, you can get all the help, and it gives you a list of stuff. These are all AOS commands, which again I'll have to do another video which shows you all that, and it gives you a rough idea what the buttons do. All these buttons, as I say, you can touch them or you can click them if you want. You only need to click them once, you don't double click them. Targets at the top. And that's pretty much the main test screen and all the different features on it. If you want to close down the tester, you have to click the button at the top, and away it goes. If you start it back up, every time you start the test program, it will reset and go back to address 0000, as it does there, and you'll get the same boot up screen. So that's pretty much all the basic stuff of the tester. There's obviously a lot more in it, hooking it up to the board you want to test, etc. But these intro videos I've just done really just give you a rundown of the basic functions of the tester. What else can I say? Oh yes, we'll go through the probe. I think I'll do another video which will just basically go through the probe stuff, because there is a little bit in the probe itself. Status button is on there, but as you see, if you click it, it's not implemented at the moment. There's been one or two little technical problems with that, so what I've got at the moment is the button there, but there's no actual software behind it. So at the moment it won't work, but with the next revision of software it will work. So for the moment the status doesn't really do anything. File name is currently set to data. You can click that and you can change that. That really tells the tester what to, when it creates a data file, for example, you can change that name there and it will create a different text file, etc. When you do the ID check, it doesn't actually create a text file. What it does is it creates a bin file instead. So it's exactly the same as the block read, but all the data is then stored in a binary file, i.e. .bin, with that name there. So that could be data.bin, for example, at the moment, and that bin file